So our try is number 63 for the last few minutes of class from section 14.7. Extending exercise 62, when you put electrical resistors in parallel in a circuit, the combined resistance measured in ohms is given by this equation. 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Great. Estimate the change in R if R1 increases from 2 to 2.05, R2 increases from 3 to 2.95. Oh, you have an increase, a decrease, and an increase? That's kind of cool. All right. So the point is, if we want to estimate these things, okay, what we want to compute is we want to compute dr. I guess what I'm going to do first is I'm going to solve for R. And when I say solve for R, because I want to write R as a function of R1, R2, and R3. Okay? So could I just take the reciprocal of both sides? Sure. Let me do it. 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. But this is kind of like I told my guys about the square roots. Don't think that that equals R1 plus R2 plus R3, because it doesn't. So if we want to add those fractions, of course, we need a common denominator. What would the common denominator be? Thanks, guys. I really appreciate your participation today. You guys rock. And the numerator becomes R2, R3 plus R1, R3 plus R1, R2. But I'm doing 1 over that. And so I'm claiming that R is equal to R1, R2, R3 divided by that crazy sum. Who asked this one? No, more importantly, who assigned this one? All right, here we go. So what we want to do next is we want to compute partial derivatives, yes?
Yes.
Because we're going to compute dr here, right? So the way it works is dr is equal to the partial of r with respect to r1 times dr1 plus the partial of r with respect to r2 times dr2 plus the partial of r with respect to r3 times dr3. And going back to the problem, remember that what happens then is you're evaluating at certain points. So let's see. It says R1 is increasing 0.05, R2 is decreasing 0.05, and R3 is increasing 0.05. So basically, I could tell you already, I'm going to put a 0.05 in here. I'm going to put a minus 0.05 in here. And I'm going to put a 0.05 in here. Now, what goes into these? That's going to be some work. I need to compute some partial derivatives. All right, let's see if I can hint at how to do that in the last minute. Here we go. Let me try just this one.
So are you just doing a partial, you're doing a quotient rule for each of those, doing partial derivatives, and then going in and when you go in to evaluate them, though, do you take the starting values?
Yes.
R1, R2, R3?
Yes. So each of these should be evaluated at 2, 3, 1.5. You're right. And can I compute that thing with the quotient rule? Is that really how to do it? Yeah, it's quotient rule. Ho-D high, so mess times the derivative of the high with respect to R1. Well, these are constants, so it's just mess times R2, R3 minus R1, R2, R3 times what? R3 plus R2. Oh, wow. All over ho-ho? Wow. and then plug those points in? What a great problem. But we're out of time, fortunately. So have fun with that one. And nice work today, guys.